Welcome, everybody. This is Robert Hodges, and I'll be your host today at our webinar on ClickHouse and Apache Kafka, getting fast insight from fast data. So this webinar is being recorded, so we will post a copy of it after this. You'll actually receive an email message with a link to the recording as well as the slides. So you don't have to take notes. We'll make the content available afterwards. Before I get too deep into the webinar content itself, I'd like to discuss a couple of key points that will help you as this webinar proceeds. We have a question and answer box that you can use to type in questions as the webinar is proceeding. If it's something relevant to the topic that we're discussing, we may stop and go ahead and present or address the question right then and there. Otherwise, we have time at the end to answer questions. Our goal is to make the webinar relatively short, so hopefully around 40 or 45 minutes, and leave plenty of time to answer your questions. One second thing is we have a poll, which we run at the end of every webinar. Helps us get a little bit of feedback how we're doing and help make the webinars better in future. So we'd appreciate if you wait around and fill that out. We'll do it after the last slide runs. Okay. Let's go ahead and dive into the content. So I'd like to do a couple of quick introductions. My name is Robert Hodges. As I said before, I'm the CEO of Altinity. I've been working on database systems of one kind or another for well over 30 years. Plus, I've done a fair amount of work on virtualization and security. Today, I'll have with me Mikhail Filimonov, who's one of our engineers. He is a ClickHouse committer, and most importantly for this discussion, he's now the Kafka Engine maintainer. We actually took over responsibility for Kafka Engine support about a month and a half ago and are now responsible for both fixing bugs as well as adding new features. Just a little bit about Altinity. We are the enterprise provider for ClickHouse. We do software and services of various kinds. They include both management software, for example, ClickHouse Operator to run cloud-native data warehouses. We also do a variety of services that include support, engineering of features in ClickHouse, also known as NRE, and things like POC support and training. We are overall a major committer. In fact, we're the #2 committer in ClickHouse worldwide, and we're a community sponsor in the US and Western Europe. So we have a deep interest in ensuring that you can use ClickHouse easily, and this webinar is part of our efforts to make that easier for everyone here. Let's keep going and dive straight into the content. I'd like to talk a little bit about what Kafka is and why use it with ClickHouse. We won't go too far into this because we assume from the very large number of people that signed up that many of you are already using Kafka and know about it, so we won't bore you with a lot of details about Kafka itself. Let's just have a quick look in case you're not terribly familiar with Kafka or this issue is new to you. So Kafka is a messaging system. I call it messaging on steroids. And so basically the way that it works is the heart of Kafka is a distributed log. And you can have producers which are pushing data into that distributed log, which can be spread across one or more nodes. In fact, in large installations, it's many nodes. And then you have consumers who read out of the log at the other end. The log is divided into what we call topics, which are, you can think of as queues. You can push a message into a topic, and then somebody else can come along and read it. In fact, many people can read it. And the topics themselves are stored in what are called partitions. So these are, you can think of the queue being divided up into pieces. For example, if we have 3 partitions here, 1/3 of the messages typically would go in each partition. And they will be properly ordered so that if somebody reads from the partition, they will see them in the same order that they arrived. Kafka also replicates the data very efficiently. So you have what are called Kafka brokers that hold the data, and in a production system, you'll typically have multiple brokers which contain replicas of the data, and that prevents it from being lost if one of them dies. One final thing in this model is that we have what's called a consumer group. That is a kind of like a catch-all for a group of consumers, people that are, applications that are reading from Kafka, so that they all properly collect messages from the topic. So I'm not going to go any deeper into this. I've worked with replication for a really long time, and so I could talk about this for a while, but it's a great system, and most importantly, it's extremely popular. It's worth talking about why it is so popular. Excuse me, before I do that, let me talk a little bit about ClickHouse. So for those of you who already know ClickHouse, you don't need to be told this, but for those of you that are new to this, let's talk a little bit about ClickHouse and what it does. So ClickHouse is an extremely fast data warehouse. It understands SQL. Excuse me. It's very portable, runs on bare metal to cloud. It uses what's called a shared nothing architecture. So you have a bunch of ClickHouse servers, well, anywhere from one to many, and those have storage that's attached to them. And so when you run a query, if it's on a single server, it'll go straight to the locally attached storage. Of course, it could be mounted over a network, but the processing and the storage are closely coupled. This is a standard architecture for data warehouses. Speaking of storage, we store the data in columns. So instead of storing it as a row, as you would in InnoDB, where if you have an accounting record, all the data for a single row would be in the same place in storage, we instead put all the columns in the same place. Those columns are highly compressed, and they're also sorted. When we read the columns, we take advantage of what's called vectorized execution, where we break the column up into pieces, and then we assign the duty of reading the column to as many cores as we can, as we have available or are allowed to use, and that allows us to read extremely efficiently on a single machine by using the cores in parallel. We also have what's called MPP enabling, which allows us to run parallel across multiple processors. So between these two things, this gives us tremendously good query speed. And every query is going to be a sequential read. Similarly, when we write, we always write sequentially. The system scales to many petabytes. I run it on this laptop that I'm currently using right now. This is a 6-year-old Dell, so really about as weak a machine as you could get. The SSD, I once looked up its rating on a website somewhere. It's rated at 0. So the performance is so poor, but I can still get pretty good performance on it. And then we have people using ClickHouse that go all the way out to clusters, including hundreds of nodes. So for example, Cloudflare has over 100 nodes of Cloudflare is a big user, not an Altinity customer, but they have over 100 nodes and ingest enormous amounts of data. One final thing about ClickHouse that's really great, it's open source, like Kafka. So if you're looking to build a business that depends on open source, or you just want easy access, it makes it very easy to use. It seems I'm muted. I apologize. Let me back up. So you have you have Kafka, which is very capable. You have ClickHouse, which is very capable. There's a bunch of reasons to use them together, and in fact, many customers do that. So so there's a number of good reasons for that, and they include the fact that Kafka supports an enormous number of just one second. Can I get confirmation that I'm not muted? Sorry about that. Okay, great. My apologies for that. The muting is a little bit complex and sometimes doesn't work correctly. So the reasons to use Kafka and ClickHouse. Data sources. So Kafka supports an enormous number of producers and consumers. We had a conversation with them with the Confluent folks who offer enterprise support, and they mentioned that there are over 800 connectors that are available to either put data in or take it out. So that's so you can talk to Hadoop, you can fetch data from Hadoop, you can fetch data from Spark. It's very easy to construct your own applications which push data into Kafka or take it out. So that's really important. Another one is that Kafka has very low latency. So you put something in, you can read it out often within sort of seconds or even fractions of seconds. So this is an important capability. So another thing is that Kafka scales very, very well. So it allows very, very high message throughput, and that's great because ClickHouse scales equally well. ClickHouse can scale linearly as you add more shards across servers. So what you want is a messaging system where you can actually balance the load coming in from the messaging system to the load that the data warehouse is capable of ingesting. And then a final reason that among many that people choose to couple Kafka and ClickHouse is that you can replay messages in Kafka. So you can deliver them, of course, but what's maybe not obvious if you haven't done this before is that if you have a problem with ClickHouse and you need to restore data, one simple way is just to replay the messages out of Kafka again and reload the data. So that's actually a very common approach among many of our users. Okay, so these are all good reasons and sort of give you the overview of these systems. Let's jump into the details. So what I'd like to do here is talk about reading data from Kafka. And we'll use a simple example. I have a very short demo that shows it in action. So basically the flow that you get is you have a topic on Kafka, and that has messages that are coming in. The way that we're going to extract this out is we're going to use what's called a Kafka table engine. And this is a specialized table engine inside Kafka that actually encapsulates the one or more topics and automatically fetches data out of them. Next, we're going to have a materialized view. This is a great feature in ClickHouse. We've done webinars and blog articles on it. But a materialized view will automatically fetch data out of as it arrives in one table and put it in another one. So the materialized view fetches the rows and stores them in a target table. Excuse me. So that's the basic flow. Let's just show how we set this up. We can do many variations on this. If you're using Kafka right now, you'll think, okay, this is kind of first grade. We'll get to some of the more advanced use cases in just a minute. Let's talk about the setup, though. So what we're going to do is create that inbound Kafka topic. And this example I'm showing is a typical Kafka topics command, which will create the topic at the command line. You notice that if you're familiar with Kafka command line, you'll notice I'm using a bootstrap server to locate Kafka, and I'm using this kind of funny Kafka headless DNS name. That's actually because all of these examples are being run on Kubernetes. So if you're running on a different in a different environment, your DNS names will obviously have a different form. But what we're going to do is create a topic called readings, and it's going to have 6 partitions. So these are breaking up the queues into basically 6 shards, and they're going to be replicated 3 times. So they'll be present on 3 servers. So that's a command. It runs almost instantly. The next thing we'll do is we're going to go ahead and set up a target table. We'd like our target table to contain, in this case, temperature readings. This is from a benchmark that we recently did that hit Hacker News, where we showed how you can read very large quantities of data just using an Intel NUC. This is that same table. And so here's the table. This is a vanilla garden variety ClickHouse table. It uses merge tree. It's partitioning by time, and it has 4 columns. So we won't spend any further time on that. What we'll now look at is the most interesting part is the Kafka engine. So we have a new table. We call it Readings Queue. It has three types or three columns in it. If you look at remember the previous table actually had an alias in it, so we create some of the data automatically. But we're going to use the Kafka engine, and then we're going to have a set of settings. And basically, these settings are very simple. They're just telling the Kafka table engine where the topic is located. So we have a broker list that can be one or more host names. We have a topic list that can be one or more topics. We have a group name that groups all the consumers. Like if there are other servers, they'll be grouped in this. And then we'll have we talk about the format, so the input format of the data so that we know how to parse it. And then finally, we have this Kafka num consumers, and that just says, for this table, just use a single consumer. That's actually a best practice for Kafka, and we'll talk about that a little bit later. So with this, we have the Kafka engine, which encapsulates the topic. We have the source table, which is, or the target table, which is where we want stuff to want the data to land. Let's now create a materialized view, and that's going to fetch the data out of the Kafka table engine and put it in the target table. So this is a relatively simple materialized view. We just select the columns and put them into the readings table. So we have actually a question about Kafka Engine development. That's one that we'll defer until later. Meanwhile, what I'd like to do is go ahead and get in and do a very simple demo. So let's have a look at this. Go ahead and show this in action. Let's move this out of the way. And what I have right here is I've got a demo where I've basically set up exactly those tables I just showed you. And I have a simple Python client that is generating sensor data for me. So here you see it on the bottom in the bottom left-hand corner. The yellow screen is actually attached to my ClickHouse server, and it's actually showing the data that's being read in after it's fetched out of the Kafka table engine and put in my merge tree table. So I have a query here which does some aggregations. I'm just going to run it again, and it will show me. In fact, let's put a limit on this. Actually, it's what you can see. I don't want to change the query, but basically what you can see is that the numbers each time I run this. Let's run it a couple times. So we see 27 is 1169 now. We run it again. It's now 1192. So the data is being fetched from the topic as it's arriving. Let's also look at prove that the data is arriving in order. That's something that we also want to make sure that we're not missing anything. So let's go ahead and run a query that shows the latest data. So coming from sensor 27, so we see that that it's coming in. We run it again. There's no gaps in the data. It's being generated every second. Run it again. We again get the latest data. Excuse me. So that's showing that the data are feeding in. One thing that's kind of fun is now we can add more sensors to this, and this is sort of the joy of working with Kafka. You can have as many upstream producers as you want, pushing into the same topic or producing into the same topic, and they will all arrive in ClickHouse without ClickHouse doing anything special. So what I'm going to do is I'm now going to add a new sensor. I'm going to call it 99 for this demo, and I'm starting my client. And you can now see data from 99, sensor 99 showing up. Let's go ahead and run our query with the counts, and now you can see 99 at the bottom. So this is now showing up in ClickHouse and is available for query. So that's basically showing the versatility of this. One thing that I want to make sure is completely apparent is this is very low latency in the sense that the data is put into Kafka and it quickly it's buffered a little bit inside the table engine. Mikhail may talk more about that, but it's as soon as it arrives in ClickHouse, it's basically instantly available for query. So this is really important if you have data that's being generated upstream and you quickly want to be able to run analytics on it. Kafka plus ClickHouse is a great combination. Let me show you one more interesting thing, and that is it's possible to get a little bit of metadata about the about what's arriving from Kafka. You know, for example, the topic name. Let's say we'd like to know where the data came from. Let's go have a quick look. I should have the query here. 1 second here. So I've actually defined a second materialized view that reads off that same table engine, and it's putting the data into another table. This is actually something you can do with ClickHouse very easily. You can take that data coming from the Kafka topic and send it to multiple places. I've sent it to a table called Readings Extra, and this Readings Extra table is using what are called virtual columns. These are data that come from Kafka itself and tell us, for example, that this came from the readings topic on Kafka. If there were a key being used, or or a different partition, we would see that in the data. So that's this demo. What we're going to go ahead and do is go to another topic, which is, or another question, which is how to write data from ClickHouse back into Kafka again. So let's go ahead and grab our slides. And we'll go ahead and make this large. And let's talk about writing data to Kafka. So this is a much simpler flow. Basically, we define the Kafka table engine, and we just insert into it. It's as simple as that. So we have the topic, which has the messages. Once again, the Kafka table engine points to it. Anything we insert into that will appear in the messages. So let's go ahead and show how we set that up. So in this case, we're going to create the outbound Kafka topic. So that is created much as we did the previous inbound topic. Very simple command. And we're going to create the Kafka table engine. So here we have the table events and a few settings. Kafka format. This one, actually this example shows CSV. I think I may have used JSON. We'll see what comes out. And at this point, we can now go ahead and insert some data into events. So let's go ahead and put this away, and actually, instead of focusing on the slide, we'll just demonstrate it. So here we are. Let's go ahead and we will stop the consumer, which was reading, and we're going to go ahead and start reading from the events topic. So we're now waiting for data that's going to show up in Kafka, and let's go ahead and pull up the insert command. Here we go. So I'm going to go ahead and insert into the events table, into the Kafka table engine, just like that, and here you go. It shows up as CSV data, exactly what we put in. If we create another different kind of error, or another kind of messages and insert that, it will also likewise appear in the topic. So basically at this point, what we've seen is the simple setup to read data from Kafka and also go ahead and write it back out again. And this gives you the ability to now develop a number of configurations that allow ClickHouse to share data from and to Kafka topics. At this point, I'd like to go ahead and turn things over to my colleague, Mikhail, and he's going to talk about tips and tricks, some sort of advanced procedures, and additional things that you're going to need to know when you're actually running this in production. So, Misha, go ahead and take over.
Hello everybody. It's Mikhail Filimonov. So I will just talk about more about like how to use it on production. So what is which problems you can face in real use cases and how to avoid them, how to use it in best way. So first of all, we'll just talk about a bit how it's built. So actually, when you create a ClickHouse table in ClickHouse, under the hood it uses librd which is one of the most advanced and most performant C library to access Kafka data from applications. And that library actually you create consumer using that library, and that consumer fetch the data from the topic as you set up. When you create a table, as Robert showed in his sample, you provide some basic settings inside inside create table statement. But beside that, there is also like more advanced settings you can reach through config XML, and you can set it up, for example, let's say debugging. So you can enable debugging for Kafka by putting debug, for example, debug all inside Kafka section in XML. Yeah, so actually that is like very high level implementation of how does it work. Yeah, and we can just check on the next slide how we can we go to next slide? Yeah, so to make that work, there is few like tips and tricks which is like which can help you to use that the most efficient way. First of all, we highly recommend you to use the latest Altinity stable version, which is now 19.16.10. There was a few important fixes for Kafka, which actually at that point exist only in that version. So if you will use another versions, you can face some issues. But that version is really like approved. We know what it's working. Every time when you configure them, when you use Kafka in production, of course you need to have high availability. To reach that high availability state, you need to have usually you need to have at least 2 in-sync brokers, and to have that high availability, you need to one extra, so you have 3 brokers, replication factor 3, and at least 2 of them should be in sync. Yeah, one of a typical problem when you when you start using Kafka is you should understand that to consume the topic in parallel, actually you need to have enough partitions for every consumer. So for example, if you need to consume the same topic with 3 ClickHouse nodes, you need to have at least 3 partitions at that topic. So if you have 2 partitions only, one of ClickHouse servers will do nothing. So it will have no assigned partition and will not able to consume everything. As Robert already said, there is a nice debugging feature to get the coordinates of what messages which was being consumed. So we can get what topic name, partition name, timestamp, key, and offset. And you don't need to declare them inside what engine Kafka. It's just you can just select them in your materialized stream. Yeah. One of use cases, one of important information here actually is when you create a ClickHouse table, under the hood it uses separate thread to copy the data from what topic to destination table, and those threads uses background schedule pool. So it is by default it has 16 threads. So if you have really lot of tables in your lot of Kafka tables in your environment, you usually need to increase that numbers. Otherwise, you can have delays because it will not have enough threads for everybody. And you can monitor how many threads are used using system events and system metric called background schedule pool task. Yeah, about what num consumers. Actually, there was a ideas of how to improve that performance. So when you reach that maximum performance of consuming, you can be not enough with that, not satisfied with that, and one of ideas of how to improve that is just let's try to create one more consumer who will be used in the same thread, in the same context, and will copy, we will consume more data and copy it with same bulks in the target table. But actually, that approach didn't work. So that settings is exist, but we don't recommend it. Instead of that, you can use another approach. So you can just create a separate table with Engine Kafka and separate materialized to streaming data to the same target. In that case, they will be parallelized. So it will be run in separate threads, and it will be you will double the performance. In case of you use num consumers, for example, num consumers 10, it actually will consume in 10 with 10 consumers, but still parsing and flushing will be done in single thread. Yeah, there is plenty of options of RDKafka, libRDKafka. You can you can check them inside that link. So, for example, you can fine-tune some timeouts. You can set up different login, different logins and stuff like that. Different way to log in, different compressions and default settings. The full list of that is under that link. So when you will get that presentation, you can just check and follow that. Yeah. Yeah, so when you have cluster of ClickHouse, what is usually you have. So you have cluster of ClickHouses and cluster of Kafkas. Usually, best practice is when every ClickHouse server consume some partition or partitions and flush row locally to its local replicated merge tree. So after that replication will work and just copy the data to our ClickHouse servers. But you don't put the data through distributed. The only exception from that rule is when you have to redistribute the data according to some sharding key, which is not available for some reason in our options. So in case you need to shard by some key which exists in data, you put the data through distributed table, and it gets redistributed according to that key. Yeah, you can do the chains of materialized too. So actually, you can build some quite complicated pipelines. So, for example, from Kafka, copy data to table A. From table A copy data to tables B and C. From table C, you copy data from to D and E and stuff like that. And from E, for example, you push the data back to another Kafka topic. So actually, you can use at that point ClickHouse as a stream engine. But for now, we actually don't recommend that because as ClickHouse is not a transactional database, those pushes of data through that pipeline is not 100% reliable because they have not atomic property. So some data can be reach deeper stages than another block of data, and you will have some inconsistencies. But work on that atomic materialized queue already started, and we expect them to have some implementation in the first half of that year. Yeah, what if you need to do something? So, for example, you need to rewind or fast forward some topic. There is quite easy to follow that scenario. So we just detach the tables from using outer clients, from using what official official Kafka tools called Kafka Consumer Group. You can just reset offsets to latest, for example, or to earliest, or to shift by, or something like that, and just do what execute. Your consumer group gets shifted forward or back, and after that you attach Kafka tables back, and it continue reading to position you desired. Also, for when you start consuming new when you start consuming data with consumer group which is not exist, it uses what out of set reset settings, so we can set it to smallest, so read from the beginning of a topic, or latest to read it from the end. Yeah, how it's work internally. So it's there is a question I saw in chat asking about how does it flush? Does it flush by rows, or does it flush by blocks? As you know, ClickHouse only accept only one way to insert data, to insert in bulks. So actually, Kafka under the hood, a Kafka engine under the hood forms that bulk for you. How does it work? First of all, it is execute batch poll. So we extract some messages from Kafka. There is a limit to, we don't spend more than half a second for that extraction, and we don't extract more than 65,000 rows, 65,000 messages at once. After they get extracted, we go to the second phase, so we parse those messages. Each message actually can have more rows, more than one row. So we can have in one message, you can have even like hundreds or thousands of rows. So for example, if you read data from, let's say you get a bulk, that natural bulks of data, you can just put that bulks together and just in one message. And after that, it will be splitted on ClickHouse side to rows. So after we have that enough amount of data configured by max block size also. So if you have that 65,000 of rows, or if we already waiting for more than 7.5 seconds, we flush that data to the target materialized use. If we don't reach that limits, so either limit by row, either limit by time, we get back to that first stage and poll another batch. So at some point we go to that step 3. So after we collect enough data, we push that data to materialized view and do commit after that pushing. So as you can imagine, because that commit happens after writing, it means that we use that at least once scenario. So if something will go wrong in between during that flushing data to materialized view, some error, lack of disk space or something like that, you will get back. It will not be committed, and you will get back to the previous position, and you will start getting duplicates at that point. Yeah, if some error happens, so at that point, error processing is quite simple. So just what Kafka client is restarted, and it leads to getting back to a last committed stage. Yeah. Yeah, there is actually Kafka Engine is not the only option how to put the data to ClickHouse. ClickHouse has plenty of interfaces. There's really a lot of different integrations, and you can talk to ClickHouse in variety of ways. So, for example, if you use, if you already have tools like Flink, like NiFi, like Kafka streams or so on, you can just actually integrate what insertions So what forming what bulks and inserts to ClickHouse into your existing tools, into your existing pipeline. So for example, if you use Flink and you like familiar with Java and all that stack, you can just use pick that official ClickHouse JDBC driver and put data from Flink, which will so Flink will read data from Kafka, form a bulk, and put that bulk to ClickHouse. And of course, you can create your own client, which will read the data from with your with technologies with the stack of technologies we're most familiar with. So, for example, Golang, Python, whatever, and put the data to ClickHouse.
Yeah, and Misha, if I could just add a word here. One of the biggest reasons we see that people build their own client or use something external is to get things like only once semantics, which the Kafka table engine does not currently support. So that's a pretty common approach to working around that.
Yes, and but it's there is few reasons when we can get what duplicates were. So as I said, what we have right now, what at least once scenario, so we can have what more copies of the same data. But actually, right now I'm working on like improvements there. First of all, we will just improve those few like corner cases when those duplicates appear, namely that when consumer group rebalance happen, we get duplicates right now, and we can avoid that using like prepared fix. And then currently I'm working on that. Yeah, and also we have some more plans in our roadmap. Yeah, maybe like you can just switch to that next slide. Yeah. So we will just eliminate what right now I'm working with eliminating duplicates during that topic rebalancing. We are planning to have ability to provide key and timestamp when producing data by ClickHouse. We have some plans to make better error processing and also to introduce exactly one semantics, which is actually part of Kafka protocol since like version, I don't remember, probably 1.10 or something like that. So Kafka in recent versions of Kafka has an ability to guarantee what exactly one semantics. So, but that means it should be actually supported by both sides, by producer and by consumer. In that case, you can have like really guarantees of what you put is exactly what you get from our side. Right now, also our format, which is really popular in Kafka world, is it is already merged, as I remember, and we have plans to make some introspection tables like system Kafka, introduce more metrics and events to get feedback of how that engine is working.
Misha, just a quick question on system.kafka and the additional metrics. Will that allow you to see lag and things like, or measure lag and things like that?
Yes.
Yeah,
that is one of like important features because at that point it is not really you can see that lag, but you need to use that external tools which will show you how far your consumer group is behind your top of a topic. And actually, we have some more like long-term works. It's not like so those plans mentioned before. It is really like short-term plans that will be implemented in next months or month. some of them next month, some of them next months. For more long term, we need to, we are planning to have to redesign a bit what problem with non-consumers was mentioned. So at what point, what adding more consumers gives nothing, or even makes worse in some cases. We need to, but it's really possible to parallelize what work, parallelize what parsing, parallelize consuming to improve performance. And of course, it should be done, but for now, it's not yet planned. Also, I know that there are plans to add more messaging systems, not only Kafka, but there is quite a lot of them, like also from like RabbitMQ, like Pulsar, like Redis pops up and stuff like that. So we are like open to discuss that. Probably it will be what things will be done in the middle of, maybe start implementation will happen in the middle of 2020. And of course, we are open to your thoughts, your ideas, and if you have some features for feature requests or bug requests, we are certainly can discuss that and make it done.
Yeah, and at that point, we're actually at the end of what we wanted to present. I just want to say a couple things, and then we'll kick off answering a bunch of questions. So definitely, you know, as Misha says, you know, let us know what you want. File issues on GitHub if you want it to run through the community process. If you have a project where there's some aspect of Kafka support is blocking you from, you know, solving a business problem, just contact us directly. We can also arrange to do NRE to make things better, or to address the specific feature that you would like. So with that, we'd like to say thank you. Please do give us feedback on this. I'm going to kick off the poll in just a second. And we do have an offer if you're using Kafka, or actually using ClickHouse in any way whatsoever. If you'd like to have an hour of consulting just to understand, you know, just to evaluate the system that you have and talk about different ways to improve it, feel free to contact us. We gladly do that, do a 1-hour free consultation, and help you understand how to use ClickHouse more effectively, as well as give you ideas about how we can help you. So our contact information is here. We'll go ahead, and I'm going to go ahead and start the poll. If you would be so kind as to fill in the information, it's a fairly short series of questions. We use this to decide, you know, which webinars to do next and how to make them better. And at this point, I think, Misha, I think we should go and talk about address the questions. The first one that's open is Kafka Engine was developed by Cloudflare a few years ago. What's the problem with their implementation? Do you have a comment on that?
Yeah, actually, Cloudflare did a good job, but it was like mostly addressed by their like internal product. But after like 1.5 years on in ClickHouse, there was few more use cases found. Like for example, they use only one format, like what Cap and Proto. When you start using another format, there is some other problems appear. Actually, their implementation wasn't really perfect. And in the beginning of year 2019, and actually Cloudflare decided they will not continue supporting that, because they just they made a big chunk of work, put it open source that, and just was expecting that, hey guys, keep going, make it better if you need. And at the beginning of 2019, the guys from Yandex pick up that work, but unfortunately it wasn't like very successful project, because actually they don't use Kafka internally. So Yandex doesn't use Kafka internally, and when start doing the things we are not like really familiar with. It's happened, but more and more different problems was start appearing, and there was really big stability issues with Kafka for the first half of 2019. After that, we start making it start bothering them, start making it better. And like last month, we just pick it to our support.
Okay. I think here's another one. Is it a good idea to use buffer table between materialized view and the storage table?
Usually it's not necessary. If it is the only exception, I can imagine if you really have a lot of teeny inserts or some, for example, let's say you group by, and your group by create what only few rows in what materialized view. In that cases, maybe it can have sense to use buffer, but usually not.
Okay, great. So let's go ahead and mark that as answered. I think we covered the topic about Kafka num consumers and why that's a best practice. That is, just to be clear, that is only for ClickHouse. Obviously, for Kafka in general, this is something that you can, and librd Kafka, you can use whatever you want. Let's see. So next one was what metrics are available now to monitor the Kafka table or lag between last written offset?
So actually, it is enough to use. You can use whatever tool which allows you to see consumer group log, because it's actually consumer group is not some abstraction of ClickHouse, it's abstraction of Kafka. So whatever tools you use for monitoring Kafka, it should be allow you to monitor the logs of your consumer groups. Yeah, so if you use Prometheus, Grafana, whatever, it should have those integrations.
Exactly once in plan. I think you covered that. In fact, that was a project that's being funded by one of our customers, and so we're really grateful that they're helping. I think we can pass over that one. There's a question here about Avro support. Does it include communication with a schema registry? And what about SSL support?
For SSL support for brokers, yes, you can configure that with FRD Kafka settings, both in XML file. For schema registry, I know what it is really hot subject right now. What Avra pull request was merged, as I remember yesterday, and that part with schema registry it was already in that original pull request. But I think due to some small issues, it was like postponed. So probably it will go in another pull request. So maybe it will be delivered a bit later, but that means like weeks after what, just Avro without schema registry. And certainly we need to have that support for SSL for schema registry.
Yeah, and as far as SSL, we have another question about SSL. In general, SSL support to brokers is covered by the librd Kafka settings that you discussed, correct?
Mm-hmm. Yeah.
Yeah. So librd Kafka is extremely capable. As Misha said at the beginning, it's really an outstanding C++ client and does a lot of stuff. Here's a great one. What happens with ClickHouse if the Kafka leader is lost or another error occurs?
Yeah, actually, if you have high availability cluster, nothing bad will happen. So it will just connect to another broker and continue. If we talk about what Kafka leader, so it should happen that it will do broker rebalances, and what leader should shift, and it will continue with another. Just normal high availability system. So if of course in some, as I said, in some corner cases, I'm not really ready to answer if it will happen with both that particular case, but we can expect duplicates. we can expect duplicates on ClickHouse side right now.
Yeah.
Yeah.
One thing one thing that we should mention is that we one of the other things we do besides doing pull requests in the code is we do a lot of test development, and that's because there are so many corner cases. It was somewhat difficult earlier to test the Kafka support effectively before we could write from ClickHouse back out to Kafka. So now that's a recent feature addition. Now that it's available, it makes it easier for us to construct tests that, for example, show data round tripping and allow us to have more confidence that we're getting the corner cases. Here's a great one, which is not strictly speaking a Kafka question, but I think it's good. Our main concern while using ClickHouse JDBC driver is to write data in batches. When writing data in batches, is that we don't know based on the exception thrown by the JDBC driver as to which record in the batch has a problem.
Yeah, actually, to that point, you can when you can look into logs. So in case when you need to debug something, you need just always to look in logs. Actually, if you will look in logs, it should show you more information. Where actually exception messages, I remember it was like improved, like in recent versions. So you should in what simple textish format you can see what exact positions of what when parsing get broken. Yeah, but still it is like I would say it is not like typical use case. So once you like get through like initial setup and configure everything to make it smoothly, you don't really get those errors often. So it's usually happen during only development process, and you need just to adjust the format to requirements of ClickHouse.
Great. The next one that comes up is: are there plans for creating connector for an Oz Kinesis broker? I've heard that on call. You know, that's a request I've heard. Misha, do you know if there's any roadmap plan for that?
No, I don't know any details about that.
Yeah.
So
definitely, if that's something that get that in, make sure that that's in as an issue, and if you need it accelerated, give us a call. That's an interesting one because I know Kinesis is pretty popular. Let's see. In the case of several servers of ClickHouse, how are the consumers distributed across servers?
Yeah, it is actually at what point it is what usual consumer group balancing.
Yeah.
So when the more consumers attached to group, it gets rebalanced, and those partitions get distributed between that group. What distribution tries to be like as equal as possible. So for example, if you have only 2 servers but 3 partitions, one server will actually consume 2 partitions, and second one will have half of data because he will only consume 1 partition. So because of that, you should always have enough partitions for all the group.
Great. Is protobuf supported with Kafka?
Yes, it is.
That's a quick one. I figured that out. Okay, great. Is there support for Kafka ClickHouse connector by Altinity? Oh, I'm glad somebody asked that. We've actually talked with the Confluent folks about developing this. We don't have one right now, and I have not seen one that looks really usable out in open source. That's something we're thinking about. If you have a question about that, please, and would like to see that, please contact us directly. We'd be happy to talk about that. Let's see. When using a cluster as well as distributed tables, what is the best practice for resilient client communications? For example, put the cluster behind F5, or each client configured to communicate with just one server with a failover to a second server?
I'm using just a bit complicated questions. I need to imagine that scenario. Yeah, so you can actually use those. You can use load balancers like F5. In general, when you have, as it always, for high availability, you need to have not if you will have single load balancer, it is a single point of failure. So it means that with at F5 you need to have two F5s, which is usually happen. If you don't have that F5s, and just try to build your own like that load balancing. You need, usually you don't, it's simpler to just allow that direct connections. Also, when Kafka client connects to broker, first it connects to what initially connects to one broker and get information about other brokers from that one. And if so, that also means that each ClickHouse server should have connections to all Kafka brokers. Yeah, interesting. There is next question. Any interesting use case of reading Kafka from ClickHouse? Yes, we have interesting use cases. We have like right now what one of our clients, it is going production soon. We're using really complicated pipelines reading from Kafka and writing to Kafka. Yeah, I'm not sure how much details can I share.
Yeah. Hey, Misha, I've got one which is okay to share, and that is log management. So I think for people who use ClickHouse, you know that materialized views are really kind of incredibly useful feature for aggregating data, but they can also be used to, as Misha says, to construct pipelines and to pull things out of tables. So for example, if you have log management and you want to detect unusual conditions or things that require immediate attention, you can build a materialized view that queries the incoming records, and then when it finds something, it just writes out to back out to Kafka. So sort of generating events or something like that is a good use case. Here's another one. If some input records are corrupted, is there any way to track it? Also, would the whole batch fail?
There is a feature which I don't really like, to skip broken messages, but it's better not to have broken messages in your stream. So what will happen? It will fail the whole batch, and it will stop consuming at that point. So it will retry. It will continue retrying consuming the same block. Every time it will stop at the same message, and currently, what you need to do is just fast forward or just enable that skip broken messages. In that case, it will go forward. But yeah.
Great. What's the limit on chaining materialized views? I think you touched on this, but it's a good question, and we can come back out.
Actually, like any reasonable limit, so it is not like physical limit like 10 or 5 or 7. So if you it is always a matter of like being performant, being like getting optimal usage of your server resources. So there is no like hard limit.
Yeah, and I think as you pointed out, though, that I think the real limit is that they're not transactionally consistent at this time.
Yes.
So if you chain materialized views, you have to be tolerant of having like parts inconsistently written across the chain. So that's an important consideration. Here's a question. Oh, this is this is a good one. How do I sync the offsets with snapshots in ClickHouse for backup and restore?
You should just use those. You just should store that virtual columns with your data. So you need to store those topics, partitions you already consumed inside your data. Yeah, as we said, it's really possible to get. And after that, you can just get back to what positions.
And then there's a slightly off-topic question. What is the way to add more shards to the ClickHouse cluster without taking downtime? I can answer that one because I do a lot of work with Kubernetes. Actually, it's already supported. So if you just need to add a shard, which is to say make a server available with, that's marked as belonging to one or more servers that are implement the next shard, all you have to do is go update the config.xml and update the cluster definition. So shards and replicas are defined in config.xml, and you can make those changes live, and ClickHouse will pick them up automatically. We use this a lot. We actually use this capability in Kubernetes because it allows us to add a shard automatically through the ClickHouse Kubernetes operator. So the question, I think what you might be asking is, how do I actually move the data over to that shard? And that's actually trickier. If you need to physically rebalance data, like take it away from one place and put it somewhere else, that's actually something that ClickHouse does not do automatically. So you'll have to build an application and actually move the data yourself. Depending on your tolerance for things like duplicates, you may or may not, you may or may not have to take downtime to do that. What many people do when they're adding shards is if they distribute, if it's time series data and they're only holding it for a week, one of the things that you can do is just put the shard in and then distribute data evenly across all shards. And after 7 days, your data will already be distributed. So there's a natural rebalancing that happens in a lot of time series use cases. We are over time at this point, in fact, quite a bit. I'd like to thank everybody for attending, and also for Misha for the. Oh, we've got some questions in the chat section. I'm going to go ahead and stop recording here because we're actually I'll might as well keep recording. Let's see, chat section. Let's have a quick look. Just 1 second, pulling up the chat. Let's see. Oh, here we go. Okay. Oh my goodness, we'll have to stop at some point here, but let's see. Okay, ClickHouse. There's a question we add to. Oh, okay. So there's a question. I'm going to skip that. In the case of several. Okay, I think we've answered all the questions. I would like to thank in particular again Mikhail Filimonov for joining us. He's, his expertise is very helpful in this topic, and we will be presenting additional webinars on this topic. We're also going to be putting out a blog article on our blog, so keep an eye on the Altinity blog. Most of the materials that you see here will be discussed in a 1 or 2 part blog article, and we'll continue to build this out to make it easier for people to understand how Kafka works. So thanks again, everybody. Have a great day, and we're delighted that you could join us. Thanks, and see you soon.
Thanks.